In this video, we're going to look at how to do the problems where we are using a graphing utility and interpreting results, but we're going to be doing specifically on this program called Desmos, which can be found on any computer with internet connection at www.desmos.com. All right, let's look at the problems we did in class. So in this first problem, we're looking at this function f of x equals 4 over x squared plus x. We're going to go to Desmos and enter it in. So we go right here in the bar over here and we type in y equals 4 divided by gives us a fraction bar, x, and we can actually click on this a squared to get it to square. A right arrow plus x gets our equation in there, and we immediately have our graph to the right. We can explore this graph by hitting the minus and zooming out, kind of seeing what it looks like when we zoom out. And we can also go back in like so. All right, let's look at the first question, which asks us to use the trace feature to determine these values. Now in Desmos, you can actually add a table. So I'm going to click on this up here, and I'm going to actually duplicate the equation and then choose Convert to Table. And it works out really quite nicely because we have right here the values we were asked for, -2, 0, and 2. So our answers are -1, undefined. That means there's no point at 0. That's going to help us in a moment. And at 2, our answer is 3. And if you look at the graph, all the points that are on the table are labeled on the graph. All right, so let's go ahead and answer those questions. So we had, when we put in -2, we got -1. At 0, it was undefined. And at 2, we got 3. The next question asked if it was continuous, or where it was continuous. And remember at the graph how it was undefined at 0, and we even zoomed out, and we saw that, yeah, even when we zoom out, it doesn't connect up there. It might look like it here, but I can actually trace this. I'm going to click on the graph, and I go up here, and as I go along, you'll notice I'm going actually off the screen up here, and it doesn't just jump over. Okay. So this has a jump at 0, and we know at 0 there's no point. So that's the main reason we know it's not connected there. So we would say it is continuous from -infinity to 0, and again from 0 to infinity. Our next question asks if it's even, odd, or neither. This particular graph is very easy to see that, oops, I'm going to zoom in, that it has no line symmetry and it also has no rotational symmetry. So our answer there is a quick, easy neither. All right, our next question asks, when is it increasing? All right, on the left here, I can just click anywhere on the graph, and you can see the whole time as I go from left to right, it's increasing. So definitely increasing from -infinity to 0. So get that part down, -infinity to 0. Then, as I come on this side and I click on the graph, I'm definitely going down, and there's some point here where it switches. And on Desmos, if you just click near low or high point, it actually will give you the coordinates, or usually it does. Apparently I did that too. Let me get rid of the table. There we go. And if I click, oh, there it is. So there's my low point. So I can't have a table, but if I click on it, it'll tell me the low point. And that low point happened at 2, which means it was decreasing from 0 to 2 and then increasing again from 2 to infinity. So decreasing from 0 to 2 and increasing again from 2 to infinity. All right. Let's look at our next equation. In this equation, we have the square root of 1 plus the absolute value of 5x. So I'm going to go back over here, and I actually can just click on this, and my old equation is there. If I wanted to come back to it, it would still be there. And I can add a new equation down here, and I'm going to do y equals the square root. There's a square root key right here. And then it was 1 plus, and an absolute value right here, 5x. I want to point out at this time that I can hit an X here and hide the keypad, and anytime I want it back, I can click here and it comes right back. All right, and here's our graph, and this definitely looks like it might be even, but first let's see what the first question. It asks if it's continuous, and we want to know if it's even, odd, or neither. And so for continuity, it certainly looks continuous all the time. I can zoom out and see, oh yeah, this thing goes on forever. So it's definitely always continuous. I can keep going like that. And the other way to check for even, it definitely looks like it has line symmetry, but I can choose to duplicate and add a table, and you'll see that at -1 and 1 I have the same number. At -2 and 2 I have the same output. So this appears even on many levels. By the way, I can also pick my own values in the table. So I could put in -10, and you'll notice it added a point right here at -10. And I come down here and I could change this 2 to 10. Oops, 10. And there I have the same answer again. All right, so far we have figured out that this is continuous all the way from -infinity to infinity, and it is an even function. And next I'm asked, when is it increasing? We can simply just look at it and see from 0 to infinity it's increasing, and on the other side it's decreasing. So increasing from 0 to infinity and decreasing from -infinity to 0. All right, let's try one more equation. So our next one is right here. G of x equals x cubed minus x squared minus 9x. So we come over here, and if I don't want to see this graph anymore and I click on that, you'll notice that it appears to still be there. That's because I have a table. So if I X out of the table, that'll disappear. My equation's gone there. And so here's our next equation. Y equals x to the third minus x squared. By the way, for x to the third, I use that up arrow above the 6 and then typed a 3 and then hit a right, plus x squared. Let's see, now I don't remember my equation. Minus 9x, and it was minus x squared, so let's change that. Minus x squared minus 9x, and there's our equation. At first glance, you might be like, oh look, that looks like it has rotational symmetry, but we should kind of pay attention to the fact that it goes only a little bit up and it seems to go farther down. I'm going to zoom in so this looks a little better, and I'm going to click right there, and it's going to show me that high point at negative 1.437.9, and there's my low point at 2.114.05. That's going to be helpful for us as we move along. All right, so the first thing is that it is neither even or odd. It sort of looked odd, only the size of those, how far it goes up and how far down are not the same. You'll notice it went up to 7.9 and down all the way down to negative 14.5. We could also go with a table to show you that. If I plug in a -2, I get a different answer than when I plug in a +2. If it was odd, it'd be 6 and -6. But here it's 6 and -14. All right, oops, I lost my equation. Put it in real quick again. Did not mean to delete that. Minus x squared minus 9x. There it is again. All right, so we're back here. I'm clicking here and getting my high and low points. And now I want to answer these other questions where I'm checking to see if my function is always increasing, always decreasing, increasing then decreasing, or decreasing then increasing. So first let's look on the interval from -3 to -2. All right, so I want to look from -3, and this is going by 2s. Let's zoom in another layer. That's going to be a little easier. So I start over here at -3. So let's see, -1, 2, 3, and I can click on my graph. There we go. So here I am at -3. I'm way down here, and I'm going to go all the way from -3 to -2, and you'll notice the whole time I am increasing. So that answer is choice A, increasing. On the next one, I'm going to go from -2 to 0. So if I go over here and I click somewhere right here, okay, there's -2. To get to 0, notice I'm watching the x-coordinate. I go up and then I go down. So in this case, it is increasing, then decreasing. All right, our next one goes from 0 to 2. So I'm going to just click on the graph here and go all the way till I hit 2. And you'll notice I have this low point at 2.1. So I'm going to hit 2 before I get to it. So the whole time I went from 0 to 2, I was decreasing. So always decreasing. Now the next one, 2 to 4, if I hadn't clicked these low and high points, it'd be easy to get this one wrong. But 2 is going to start just before 2.1, and it's going to actually go down and then clearly just head up. So this one decreases just a wee little bit before it goes up. So decreasing, then increasing. All right, I hope this is helpful to using Desmos for these kind of questions.